All right, well, welcome. My name's Rick Crooks. I'm with Mutual Materials Company. We're producers of masonry and hardscape products here in the Puget Sound area in Washington, Oregon, lower mainland British Columbia. I have a plant in Boise, Idaho as well. So we've been doing permeable interlocking pavers for about 15 years now. My background is in civil engineering. My degree's in civil engineering, but I'm not a licensed engineer. I don't practice. I've been working in the sales and marketing of masonry and hardscape materials for about the last 35 years. So we're going to go through some of the design information you have. We've been over the basics of all permeable pavements, but we're going to go through some of the specifics about permeable interlocking concrete pavers and give you some information for design sources there, some of the different components that make paver systems a little bit different than the other two that we are typically familiar with. We'll go through some construction slides and look at different sections that we can use in permeable interlocking concrete pavers. That's that acronym PICP. And then we'll look at some structural considerations too. So a great resource, very easy to remember, it's the icpi.org website. ICPI stands for the Interlocking Concrete Pavement Institute. It's a great technical resource there online. Most of the slides that I'm showing here are from some of their training materials. But if you go to the design section of that little row at the top of their website, the design tab, and go down to the design section on the left-hand side, you'll get a lot of the technical information that you need. ICPI is a very good resource to be able to help get through the proper design, construction, and specification of these systems. I just note from the experience that I've had in the last 15 years working with permeable pavement systems, everything that Matt and Chris and Curtis have been saying about these various systems is they do work. I still see a lot of skepticism amongst engineers about their ability for permeable pavements to do what we say they're going to do and be part of a low-impact development strategy. But what I've seen is usually, and especially with the paver systems, what we usually see being the problem is lack of attention in the specification of the materials. Either the specification was wrong, or a contractor put in the wrong materials, tried to substitute in materials, those types of things. That's where we seem to run into problems in the industry. If the industry specifications, even the early ones that we've gone through several years ago, even if those were followed, the pavement systems all typically work, and they work well. This is the 4th edition of the ICPI's design manual. It handles the design, specifications, construction. It's a great all-around manual. There is also some design software the industry has. You can get that online at the ICPI website. For use in Western Washington, it's probably not as effective because it works on single event modeling, which we have the Western Washington hydrology model, which is a continuous model, but it still helps in that balance of hydrology or hydraulics in the structure of the system. Things that we do a little bit more to increase the structure generally tend to reduce the hydraulics and vice versa. So this helps balance that. You can kind of trick it a little bit, design according to your depth of your reservoir according to the Western Washington hydrology model and some of the other models that we've talked about, and then go back in and check. It's just a spreadsheet. It's a software program on an Excel spreadsheet, but it works very well. ICPI also has a wealth of design details, both in AutoCAD format and in PDF, so you can see them easily. Guide specifications, there's videos on there about cleaning and maintenance, as well as instructional videos, and there's a wide variety of technical papers available on that website too for your reference and looking at. So this is kind of the diagram of the system. We're going to look at each of these components kind of one by one, look at why we need them and how they're put together and what the appropriate materials are. So we'll first talk about the concrete pavers themselves, or the wearing course. Permeable interlocking concrete pavers come in many shapes and sizes. There's a lot of variety for different reasons. Some are patented and proprietary, others are very universal and open. So helping to know that will help you through your specification. Virtually, you take the same paver and add different textures, tumble them, or add a slaty texture to it, or different colors. You can get from one shape, you can get a wide variety of different looks. For permeable interlocking concrete pavers, there's really two ways we get the permeability. The paver itself is solid concrete, but there's no difference between the paver that you use in a permeable application and the paver you use in a non-permeable or an impervious section. The difference is the openings or the joints are wider and they're filled with free draining material that allow the system to function as permeable. And so the specification for the two products is the same. And that probably generates some of the confusion with pavers. I've heard some people say, well, it's a paver driveway, so it's going to infiltrate. Well, it will. Just a regular sand joint, small joints about a 1/16 to 1/8 of an inch. It will for a little while, but that'll eventually be clogged up. So you want to make sure that you're using permeable interlocking concrete pavers or pavers that were designed for use with permeable systems. But the materials and the specification properties are the same. Pavers have to act like a paver, not a slab. So they're limited in their area. They're limited in their size, their minimum thickness, 2 3/8. Permeable applications, we don't see anything used much less than 3 inches. The compressive strength is the same. It's very high. It's a very high strength concrete, 8,000 PSI. 24-hour cold water absorption and freeze-thaw durability tests help to keep the product durable in freeze-thaw environments. There's limits on abrasion resistance and dimensional tolerances as well. The additional thing that may be a little unique to pavers is this concept of aspect ratio. And that's basically the ratio of the length of the paver, the longest dimension on the paver, to the thickness. For different applications, the aspect ratio does kind of govern what you can use. If we had a paver that's 3 inches deep and 9 inches long, and the longest dimension, that has an aspect ratio of 9/3 or 3:1, and you can see that could be used in a vehicular application. The same paver, though, 12 inches long, 3 inches deep, that would be a 4:1 ratio, and that would be suitable for residential or pedestrian applications, but not for vehicular. And that has to do with the bending, and you know, we talked a little bit, Chris talked a little bit about modulus of rupture for permeable systems. It isn't a difference. This is the same for permeable and impermeable pavers, but it just helps you keep the paver to a module that is going to be suitable for use in an interlocking pavement design. So that's something to realize when you're working with pavers, and there's a lot of different systems out there. They're starting to get big. We see a lot of interest in bigger and larger format pavers, but they behave more like slabs, like what we have out here in the plaza area, as opposed to an interlocking concrete paver. So we have to have depth. The other question that we get typically is, are these things ADA compliant? And so there isn't really a test for ADA. ADA sets guidelines, and do they meet these guidelines? So you go to the 2010 standards. They talk about floor and ground surfaces that are to be stable, firm, and slip resistant, and comply with their other parts of the section, basically. And you want to have products that basically don't slip. Concrete pavers are out of concrete. Concrete's a familiar finish, so typically we don't see a problem with that. The openings, however, is an area that people do start to question. So some of the earlier interlocking pavers that our company made had larger openings, and so we reduced those to comply with these ADA requirements, and so we made smaller openings. And basically it says you don't want to fit a 1/2-inch diameter sphere through any opening in the pavement. Pavers, even on those older pavers, when it's filled with aggregate, you're not going to get a 1/2-inch sphere to go through the aggregate. Still, if that aggregate happened to leave or if it was evacuated out, it sometimes could be viewed as being not ADA compliant. So you're seeing paver manufacturers now manufacturing smaller joints and things that will be able to be compliant with that 1/2-inch sphere requirement. The other issue is slopes, lippage, and a 1/4 inch is the lip. Now most pavers have a chamfer on them, so it would comply with this requirement in ADA. These are all excerpts out of that 2010 ADA guide. So a 1/4 inch maximum lippage, and then if you do have more than a 1/4, you can have a bevel on it or a chamfer on it. It can be higher. Properly installed pavers are perfectly flat. Good installers don't have a problem with lippage, and you can put that in your specification. In fact, ICPI guide specifications have information on there for maximum lippage for you to include in your specification. So that's the paver itself. The next is the joint fill, or the material that goes between the pavers, and that's aggregate. And that aggregate is typically, that we use the terms out of ASTM D448, which is aggregates for road and bridge construction, and we use it as we call it a number 8, which is there's a schedule there, the table in that specification. Number 8 is just a specific gradation. So you hear this number 8, a lot of local quarries will look at you like, is there a WSDOT number? That's the same for these materials. There's different gradations of materials in there. We also typically see it as a 1/4 inch chip. And so if they don't have that, find out what your local quarry does have available in that 1/4 to 3/8 inch. It's basically everything that's below a 3/8 inch sieve, enough to fit in the joint. What determines the size of that aggregate is your paver and the width of the joint. You can't get 1/2 inch rock into a 3/8 inch joint. but you can get 1/4 inch rock into a 3/8 inch joint. So pay attention to what your paver is, match that up with the aggregate. In the joint fill, you can use finer aggregates, and that's the last statement on this slide here. But it's not just gradation that we're worried about. This is critical. If you can only take away one slide, burn this slide into your memory, because this is the properties of the aggregate and pavers that we want to have. We want them to be angular crushed rock, about 90% fractured face. Mark probably touched on that earlier. Same thing for use with the asphalt. We do not want to use, and it's very common because the gradations are very similar, pea gravel. Okay, we don't want to use rounded pea gravel. We want to make sure the material is hard and durable. So we specify an LA abrasion of less than 40. There's an ASTM test for that. And then the last thing is fines. I prefer to see gradations with less than 1% fines, but the industry recommendations are actually 2% fines. So anything of those three categories besides the gradation, and make sure we have the proper size of aggregate, we want to make sure that it's crushed, 90% fracture face, durable, hard material, and no fines. That's the joint. Now let's look at the bedding layer that's sometimes called the leveling layer beneath the paver. And this is just as it's described, to be able to bed the paver. We typically use the same as the joint material if you're using a number 8, if you're using, which is the 1/4 inch. If you're using finer rock in the joints because you have a smaller paver, you wouldn't use that finer material, still use the number 8 in the bedding. For bedding and joining, you can use the number 8 with this gradation. For the joining material, next column over, and then the next column over after that, the number 89 and number 9 are successively finer gradations of a very similar material. All the material will wind up looking like chip rock. It's not really a sand. Some quarries may call it sand, but it's a crushed rock, and you want to make sure the same principle applies here. Hard, durable material, 90% fractured face, and no fines, or less than 2%. Passing the 200 sieve. Okay, then we have in permeable pavers, we have this base course and a sub-base course. Both are kind of considered as part of the reservoir. The base is there as a smaller gradation of material, and that's sometimes called the number 57, 5/8 to 3/4 crushed rock. The same requirements, depends what the local quarry will call it. Again, 1 inch clear crushed, 1.25 inch clear crushed, 3/4 clear crushed. Really doesn't matter the specifics of the gradation. Generally, they will follow pretty close to this. But we're just providing a layer there, so the larger rock beneath, which will cover that specification in a minute, that gradation in a minute, the bedding layer, the small 1/4 inch stuff, does not filter through and get lost into that larger rock. So this is a choke course. In aggregate terms, we typically call it a choke course. It's not choking off the water. It's choking off the aggregate. So the water still is going through. This rock here is still about 30% or more void area. So it's going to let a lot of water through, but it is choking the smaller aggregate in the bedding layer from entering in and filling up the sub-base below. All right, let's look at the reservoir course here. The open graded sub-base, we call it in the paver side of things. The gradation is a little bit larger. Up until this edition of the manual, which was in 2008, 2009, we were using the number 57 full depth, the 1.25 inch, 1 inch crushed. Found that had a little bit of a problem in rolling a little bit. It tended under loads to not so much once the paver was on top and the system was confined, but in the installation process, it was very hard to keep stable. And so we went to the larger number 2 aggregates, which is really often referred to as permeable ballast, railroad ballast. It's a 2 inch to 3 inch crushed rock you see in the gradation here, and very large stone and large aggregate. That's what makes the base and the structural base, as well as the hydraulic reservoir course for permeable interlocking concrete pavers. Again, the same properties are there. There's 90% fractured face, no fines, and very durable hard material.